welcome to GPN, Gulasch Programmiernacht 2025. It's day 3. We're talking about home automation and what you can do with Go and the Raspberry Pi. Please welcome with a very warm applause for my 2025 Linux and Go self-hosting stack, Michael Stapelberg.
Thank you so much for the introduction. Welcome, everyone. I'm very happy that you all came to my presentation. I have a blog which you might be familiar with. If not, I would ask you to subscribe. You can also follow me on Mastodon. I'm going to share all of these slides afterwards. It's a lot of content, so you don't need to take any notes. So we have a fully packed agenda for this presentation. In the first part, I want to motivate what is self-hosting, why do I do it? Then I want to explain which services in particular I do or do not self-host, and some of them I even self-build. Right? A specific example of that will be my home automation, or smart home if you want to call it that. I'm going to explain to you how I implemented that using my very own Gokrazy appliance platform, and then we're going to switch gears a little bit to zoom out again and go from hosting stuff inside the home to hosting stuff for other people or for yourself outside your own home. So in the first part, what is self-hosting? Fundamentally, I think it is you run services yourself instead of relying on others to run them for you. This is not at all a new concept. I personally ran my first self-hosted web server in my child's bedroom on an old PC that I had with the Apache web server that you could just install back then. And that was almost 25 years ago, right? So in this talk, I want to explain why I do it again now after taking a little bit of a break in self-hosting and how I do it. And spoiler, it's all Linux, of course, and it's mostly Go. So for context, why do I self-host? I think the reasons will be different for many of you, but for me, I think having more privacy is nice in the sense that I do trust actually the security posture of the big cloud providers and so on, but it's just more people work there, so more people can come into contact with your data. And for some of my data, I think the last decade plus of photos, I just want to have it closer to me. Also, I will have more control if I self-host, because providers or any other organization can maybe suddenly have to stop service to me, right? And we've seen numerous examples in the recent times of political or otherwise providers stopping service. If I run these services myself, I am in control, and the technical term for that in the business world would be business continuity, right? It's a risk to rely on others if you could also do it yourself. One of the things that I didn't really expect going into this exercise again is that actually self-hosted services are often faster, they give you more speed. And that is, I think, because often you host them either on the same local area network, of course it's going to be fast then, or at least network close, right? So if you host stuff yourself, probably you'll do it in your own city or at least your own country. You don't have to send data over to other countries, which might be slow. And notably also, you will provision your services with more capacity per user. Because if you're the only user, or there's you and your family or your friends, that's only a few users. But all of the big cloud providers, they play the big game of many, many users, right? And then lastly, I just like the stability. And I want to be clear, it's not reliability I'm talking about, it's stability, for better or worse, right? Which means that things change on my schedule. So if I want to do an upgrade, I can decide, okay, today is a good day to upgrade to the new version of my music player, which changes everything. But of course, that has to stop somewhere, so you're still using software that somebody else is developing, so you don't have absolute control and stability. So for which of the services does that actually apply for me? One of the things that I have self-hosted for a long time is my media library, and I expect many of you are in the same situation. I had always known that physical media, like DVDs and CDs and so on, which are the media on which I got into buying my preferred movies and TV series, they will become unreadable one day. So I had always backed them up to disk, and by now, most of these actual media disks have some sort of problem, cannot be read anymore, and so on. So that was clearly the right move. Back in the day, that meant that you would typically run something like Kodi or some other media browser or media player program on what used to be called an HT PC, a home theater PC. which you would then connect via HDMI to a TV, add like a little infrared remote and so on, right? Kind of like, the Apple TV that you can just buy these days, or Google TV or whatever. So the more modern take on this would be to run something like Jellyfin or Plex or whatever, and those have like corresponding TV OS applications. So on a modern TV, you can just use these media collections. The benefit of self-hosting your media library, of course, is that your own catalog will never just remove your favorite movies and series, but Netflix might. The disadvantage is that if you are the person who is in control of your catalog, you also have to add new things to it, so your collection will not automatically be extended. Then music streaming, right? It's very similar to like the media library, which is mostly for like TV shows and movies. With the music streaming, I actually used Google Play Music for like, I don't know, 10 years or so. And it was really cool because you could upload your own media collection to it and then also use like the streaming catalog. And my music collection is like 90% weird stuff and 10% streaming stuff. And then they shut down the service in favor of YouTube Music, and you could migrate to YouTube Music, but you could not take your own collection with you, and they have no feature anymore to upload it. So what am I going to do? I want to keep listening to the music I collected, right? So back then I got a paid subscription to Plex, which is an open source solution. I used the Plex AMP application on my phone, which was like a specifically created for music streaming thing that Plex provided. And I ran a Plex Docker container on my NAS for the server part. But it had these annoying bugs, like gapless playback wouldn't work, and the app just in general never got better. And it really annoyed me because so many people reported these bugs, and we were all like paying them subscriptions for developing the software, and they just didn't. So nowadays I use a different solution. I canceled my Plex subscription also when they stopped allowing Plex on Hetzner, because like I actually run part of my stuff on Hetzner, so I was like, So now I use Navidrome, which is written in Go, and it's nice. It supports the subsonic streaming protocol, which is what all of these music streaming things use. I use the Amplify app on iPhone. If you use subsonic and you're not using Amplify, strong recommendation for Amplify. It's really nice. It works really well. The Navidrome web interface, it works okay. It's good enough to open like a media player when I'm on my work computer, but not much beyond that. The benefit or the disadvantage is that, of course, if you maintain your own music collection, you will have to buy the music, and that is at a higher cost compared to just having like a Spotify subscription. But actually, it seems like the streaming media business model is so broken that that seems like a good thing to me, that I have to give the artists more money so that they can actually exist. So I actually prefer buying on like Bandcamp and Qobuz and all of these other services. One of the other things that I'm currently trying to self-host, but I haven't quite set it up fully, is my photo library, because I used Google Photos, which had like a great UI and surprisingly good search. But now I feel like I just want to have my collection more private. So I'm looking into running Image on my server and the Image app on iPhone, and the UI is very polished. And of course, this is much faster for some reason. So if I open up my photos and browse them on Image, it's faster than Google Photos. And aside from all of the other benefits we've already talked about, there's this fundamental freedom that open source gives you, which is that I talked to a friend recently who lives in Germany, and even though Germany legalized cannabis, if you enter cannabis into Google Photos, it will always show you no results, right? And like with open source software, you could just go into that block list and just remove the terms you don't like, right? I just think that nothing should stand in front of you and your photos, right? So yeah, self-hosting it is. So switching gears a little bit, switching from personal stuff to stuff that I host for the public. I have a couple of open source projects for which I run websites that mostly consist of static file collections. So I use like different static site generators. And I used to just put that onto GitHub pages because it had the advantage that it is visible infrastructure in the sense that contributors could come to the project and just look at, oh, yeah, sure, that's your pages thing. I know that if I want to change your website, I'm just going to change that file, right? The problem always was that GitHub Pages is sort of slow and US only, so I added Cloudflare for the DNS hosting and the content distribution and the caching. And that works pretty well, and it used to be like a really attractive offering, like it was free to use Cloudflare for that purpose. You could add TLS, which nowadays is like table stakes, but back then it was exciting to not have to deal with it. You can add rewrite rules for like little issues where you needed like a redirector or something, and you had an API for DNS updates, so you could do DIN DNS and so on. So I was pretty happy with like the Cloudflare and GitHub Pages combination for a long time. But nowadays, I really think that any dependencies on US services pose a continuity risk, and I just don't want my open source projects to be beholden to anything US specific if I can make it any other way. So nowadays, I just use the Caddy web server and the core DNS server on my own router, and I'm going to explain in more detail later how that works. The benefit is that actually this was pretty easy to configure, and it's actually also much faster than the previous setup. So every aspect of it is faster, like pushing new data onto it is faster, serving data is faster, at least in Europe, because of course I don't run like a global CDN like Cloudflare. So now it's the users from the US who have to wait a little bit longer, I suppose. So switching gears, once again, this was stuff that I self-host, but I use software that other people have provided. What do I self-build? This would be my smart home automation. So for this, I have intentionally picked somewhat open systems so that I can then interface with these systems. So I use MQTT as a central message bus, and I have a component which I call Regelwerk, which is like the rule control program in English, roughly, which just integrates all of these different components. So I have like for each vendor that I have devices from, like Philips Hue or Shelly, I have like a Shelly to MQTT, I have a Hue to MQTT, and so on. And the benefit and cost is, of course, that I have full control over all of the functionality and behavior. But, of course, it's also a lot more effort to build that and configure it compared to an off-the-shelf solution like Home Assistant, where you just click a couple of times. Another thing I self-build and want to keep self-building is daily backups. I consider myself a backup minimalist in the sense that I used to use systems like Bacula or Arclone or Borg Backup, but these days I just don't want to use them anymore. What I want is per file access whenever I like delete something or move something in the wrong place without any custom tools. I don't want to like have to mount a Fuse file system and then it doesn't work anymore, or run like a restore command that needs to look through all of like the full and incremental things and then just restore a thing. No, I just want like a directory with files, right? Similarly, I want zero setup needed to be able to restore my data if any of my network storages like burns down and I can just barely recover the disk but nothing else, right? So whenever I have just like one of the disks of my network storage, I want to be able with any Linux live distribution to like boot up and mount that data, right? It just needs to be there. One other thing I want to avoid is circular dependencies. So for example, if I have like an Arclone setup and it needs a key file, and then once my PC dies, I realize, oh, the key file was only inside the backup or the PC, but now I don't have it anymore, right? So I always have like sort of a passphrase that I know on all of the disks that are encrypted. And then lastly, I just use rsync with rsync /link dest flag for incremental backups. And it's like, I wrote this like little wrapper that just looks at when was the last backup and then just link dest on the last one. And that's all I need for like 10 plus years, right? So you don't need a complicated backup system necessarily. So then that is sort of like the system level view of it. Where do I actually copy my data onto? The storage side of it, I run Linux on 2 separate PC NAS builds. I'm going to show you those later. And on these, I use Lux for full disk encryption, and I use ext4 as the file system on one of the builds and ZFS on the other, just so that I have some sort of variance in there. And if one has an issue or if I screw up the operation of one of them, I can still go to the other. This has worked spectacularly well. I used to run this setup with hard disk drives because you could only get like large capacity on hard disk drives. The only thing that sort of annoyed me in that setup on the hard disks was that if you wanted to like delete all backups to clean up space, it would be a long operation because of course it needs to look through all of the hard links and cross-reference. But this is fast on SSDs nowadays. So nowadays my storages are all SSDs, and like this system, beautiful in today's hardware. So of course, in terms of backups, I follow the 3-to-1 rule. So I have 3 copies of my data, 2 of which are on separate media, and one of them is offsite. All right, so now I showed you a couple of things that I self-host, but there are also things that I do not want to self-host. What are these and why? One of the things I do not want to self-host is email, right? So I use my own domains, and I always have. So for example, you can reach me at michael@i3wm.org. But I outsource the actual email hosting of like the servers and especially like the delivery to other IP addresses. I used to actually run my own email server, and then I was at a CCC camp hundreds of kilometers away from my server, and it died. And I couldn't access my email for the entire week of camp, and I had to like coordinate the details of this internship that I did in an entirely different country. It was just super stressful. So I was like, okay, I need email to be more reliable than this, right? So either I would have invested the time and effort to run like a reliable setup, or I just outsource it. And back then, the thing that I noticed is that the Gmail spam filter was just so much better than open source. Like, it really made a big difference in my day-to-day, where previously I was just getting and sifting through so much spam, and with Gmail it was just nothing. So a similar service where I also don't necessarily want to get into self-hosting is Mastodon, believe it or not, because running a one-person instance means that I have to do all of these federation policy decisions and abuse handling and so on, and I have these weird bugs where like it doesn't properly federate, so I'm just like, oh no, man, I just want to have my own name and control that, and then I move from server to server, and I can keep my followers, and I think my posts might be deleted, but I don't really care about that, because I just link to my blog, and anything that is for eternity is in the blog. So yeah, I think the thing I'm trying to say is that it depends on you personally, what services you think deserve the effort to self-host, and where are the services where you think, okay, I would rather have somebody else deal with that. One of the things I definitely do want to do on my own is home automation and smart home. So first of all, to give you like a little bit of personal context. So I also work full-time, like many of you probably, which means that I have little time per se for other things. But I do have a little bit more time than some of you because I don't have any kids. And I also find this stuff pretty fascinating. So to me, it's kind of like a hobby, and you might have other hobbies. But with all of that said, I do prefer simple solutions that stand the test of time over complex solutions that are flashy but turn out unreliable. So the goals for all of my infrastructure, including my home, is that it's hands-off as much as possible. It should be self-documenting. It should be as uniform as possible, so that if there is a problem, and inevitably there will be a problem at some point, I can do quick and painless recovery. So one of the things specifically is that after power outage, everything has to come up. So I do not want any systems where it's like, okay, if you reboot it, it asks you for a passphrase before your lights start to work, or something like that, right? It just has to work. So that also means that power cycling must always be a viable troubleshooting strategy, right? So for example, while I'm here at the conference, if my girlfriend at home goes like, the lights don't work anymore, I can be like, oh, look for this power switch that's labeled that, plug it out, plug it back in, and then it should work, right? And the other thing I always keep in mind is the failure domains. So first of all, the failure domain itself means that if, for example, I want to upgrade my NAS and I screw up the upgrade, I still want my router to work, right? And if I screw up my router, I still want my home automation to work. So the failure domains just must be separate. And similarly, I also think about privacy domains. So I try not to mix private and public data on the same machines, but rather I think, okay, if I have like, for example, my router, it could also work as a server because it only deals with like public data. But for example, my private photo collection, I don't want to run on that same server, right? So in practice, I just always count on a breach. Like sooner or later, there might be an attacker in there, and then think about what can that attacker exfiltrate. So, and let's get into home automation specifically. So I tried a whole bunch of systems over the years, like the IKEA stuff, for example, returned it all, it was not good. You can look at my blog post for a recommendation of things that I like and that I don't like. By now, I have sort of developed a preference for developer-friendly devices. So for example, I have this energy meter from Shelly, which is great because it supports MQTT by default. You don't even need to like flash a separate firmware or anything. You just go into the advanced settings and be like, that's my MQTT server. And similarly, if I can't get a device that is so developer-friendly as that, I will at least use the device that has like an official API and a significant user base and is just well supported in the community, such as Philips Hue for my lights. I tried using Zigbee directly, but that turned out to be too inconvenient. Like, it's so under-documented and you run into these weird issues and it's just not fun at all. So my strategy, as I explained earlier, is to centralize everything onto MQTT as the single message bus, because MQTT is so easy to integrate also in your own microcontroller projects. So if you build like an Arduino, you can just add a library, and in a couple of lines you will have integrated that into MQTT. And similarly for vendors, it's also easy to just add MQTT to their products. For other things that don't support that, you can either use something off the shelf, like Zigbee to MQTT is a very popular component that does sort of the mapping from many devices onto MQTT, or you can just custom build something. So for example, I wrote my own Hue to MQTT and Nuki to MQTT and so on. So there are, of course, a lot of off-the-shelf solutions like Home Assistant or Node-RED or maybe others, like maybe something from the home automation vendor that you bought. But I actually enjoy writing and maintaining Go code more than learning some other strange DSL. or user interface. So in my Regelwerk, the control loop program, I have this interface that defines a control loop, and it's very simple. I just have this status for human introspection, so I can debug it. But aside from that, the principle is that everything just processes an MQTT message, and it can then, in reaction, publish either no, one, or any number of reactions to it. And it's very nice to centralize your entire home onto this model, because then you can test your entire home within that sort of model. Right? And I have a blog post which goes into more detail if you want to learn what that means. If you want to look at the source code, it's all online. So to give you an example for how this works, let's take a scenario. So in my kitchen, which I consider sort of a work space, not a living space, when I go into the kitchen, I want the lights to just turn on. I might have the hands full. I don't want to like fumble with the light switch. So I have a motion sensor by Shelly and lights by Philips Hue. So what do we need for this in my setup? So I have the Shelly to MQTT component, which accepts an HTTP request from the motion sensor. Like in the motion sensor, you just configure an HTTP endpoint. That's how Shelly works. And then my control program detects that motion, the loop runs, the interface says, okay, sure, these are the MQTT commands to turn on the Philips Hue lights. And then the Hue to MQTT accepts that command and pushes it into the Philips Hue API. So that means that we have 3 programs involved into something as simple as turning on the light, and they all need to run 24/7. So how do I run programs 24/7 in my home? I think the best choice for that for most people is most likely the Raspberry Pi or some other single board computer. Specifically, I recommend the Raspberry Pi over microcontrollers, for example, because you can run Linux on it, you can run Go on it, and you can do that on even the very first Pi that was ever released, which came out in 2012. It's still plenty powerful to do sort of this home automation stuff. It might not be powerful to like run Docker containers of Home Assistant and so on and still be snappy, but if you control the code, it's still plenty powerful. For smaller devices, like for microcontrollers, I have some microcontrollers in my home. For these, you could just use Arduino or maybe TinyGo. I was just at a Go conference earlier this week, and like the progress on TinyGo is amazing. Do check it out if you're interested in Go and microcontrollers. But I like to use Raspberry Pis, and the way that I like to run my Raspberry Pis is with the Gokrazy appliance platform. So let me tell you the origin story of Gokrazy. Back in 2012, I was part of the Raumzeitlabor hackerspace in Mannheim, not far from here, and we were working on different projects for automating that space. For example, the house bus project, where we just wanted like a bus system for our home, kind of like a very early version of a smart home. And we were working with all of these microcontrollers, and it was a huge pain, and we weren't just really getting anywhere because everything took weeks, and it was hard to debug, and so on, and so on, and so on. And then the Raspberry Pi was released. And I was like, wow, we need that. We need to say goodbye to microcontrollers, just use that, install full Linux, run it, and we'll be done. And that worked. It worked beautifully. So we have this smart lock project, or we had, like I think by now a new version has replaced it. And we needed like a Raspberry Pi appliance for it. So what I did was I wrote this shell script which builds like a Debian installation that is read-only, because it turns out that whenever you have like an appliance and you run it on like an SD card or some other flash media storage, the media storage will be the first thing that breaks because you write to it too often. So if you have a read-only system, that takes a lot of writes out of the equation, and then your system will just run much longer. Ideally for many years, and this particular system did run for many years without problems, so it was great. But the big problem is that this approach was so custom with the custom script and the installation and so on, that even though it worked reliable, it was just too time-consuming and too specialized for anyone else to ever update, which is why that installation back from 2013 was still running many years later. So in 2017, I experimented with a better approach, specifically for Go. And sort of my introduction to operating system development was when we were at Chaos Communication Congress and we were in the hallway sort of thinking, what really do we need to run stuff on the Raspberry Pi? Like, shouldn't it be possible to just... And then we opened up our laptops and we were just entering like this command with the cgo enabled equals 0, which turns off any dependencies on C code. And then go arch equals ARM64, which tells Go to cross-compile, and then you just build your code. And you could copy that binary onto the SD card of the Pi and just change the config so that the Pi would boot into that program, and then it all just worked on first try. And we didn't have to install anything. And I was just like, wow, that's mind-blowing. That's so cool. Like, anyone who has Go installed on their computer can build software for the Raspberry Pi, and it will just work. So I was like, okay, that's a great starting position. So could we have a system which builds on that and can easily be updated over the network and is stateless and read-only, just like the other appliance I built, and it would be easy to deploy Go packages to it. Like the 3 programs I need for my home, just deploy them onto that Pi. And that's what Gokrazy is. It's a from-scratch appliance platform built entirely in Go. So in Gokrazy, you have 4 moving parts. You have the Linux kernel. Of course, we can't replace that easily in Go. Like, it's a huge body of C, and so we just use the Linux kernel. Then you have binary blobs and other firmware files which you might need to start up your computer. Like on the Pi, there are some binary blobs. But if you run Gokrazy on a PC, you might have other binary blobs or none. Like, it depends on your system, obviously. The third component is the Gokrazy Go userland. So I'm going to show you what that consists of in just a sec, but that's entirely written in Go. That's what we provide. And the fourth part is your applications, like whatever you want to build, that's the idea. But specifically, you will have no C userland or runtime environment at all on these systems. You will not have glibc, you will not have OpenSSL, you will not have XC or anything like that. So how does it work? There's gokrazy.org/quickstart, but just very briefly, like, as soon as you install the Gokrazy tool, the Gok tool, you can say Gok new. It creates a new directory with your config file. And from then on out, you can use Gok override. You enter an SD card. You put the SD card into your laptop. You say Gok override -- full to override the full SD card. And then you put that in the Pi, and off you go. Once you put it in the Pi and you boot it up, you can access that Pi over the network with this web interface. This is sort of the unified Gokrazy supervision interface. Going from top to bottom, you can see at the very top, it has like the Gokrazy revision, the host name, and the model of the hardware, kernel versions, like any sort of versions that you might need to identify which version is running on the device. Then you have a list of all of the services, and you don't necessarily need to read that. I'm sorry that the text is so small, but the first couple of services are in /Gokrazy/, and these are like the minimal userland components that we need. So for example, the DHCP component obtains an IP address so that you can start using the internet. The NTP component synchronizes the clock because the Raspberry Pi doesn't have a real-time clock that persists across reboots, and so on. And aside from that userland, the other components that you can see here are all sort of home automation components that I'm running. So you might be able to decipher like a hue to MQTT and the Regelwerk and so on. And then at the bottom, you have like an overview of the memory that is used by the various services on your system and the storage that you have. And this might be one or multiple mounts and so on, and you can just see how much free space you still have. So if you wanted to run Gokrazy, we have a whole range of devices that you can run it on. The cheapest and smallest supported platform is the Raspberry Pi Zero 2W, which runs at only 1 watt of power consumption, which is just amazing. You can power this device using a micro USB plug, so you don't even need your own power supply. You might be able to find like a spare USB port on your router or something, and you can just connect that Pi to it. And then you can connect it to your home network using Wi-Fi. That's what the W in the name stands for. And in fact, Gokrazy supports encrypted Wi-Fi without relying on WPA supplicant or anything like that. Personally, though, I prefer Ethernet over Wi-Fi whenever it's possible, so that anything goes over Ethernet and only the stuff that can't go over Ethernet uses the Wi-Fi. So I prefer running my automation on the Raspberry Pi 3 or the Pi 4. The Pi 5 is also nice, but it's not actually yet supported by upstream Linux. You need the Pi kernel to run that. So to give you sort of an overview of the supported platforms, on the bottom right is like the Pi 3. That was the first device on which Gokrazy was created. To the left of it, you have the Pi Zero 2W. It's a lot smaller. On top of it, the Pi 5. As I said, it still requires the foundation kernel, not the upstream kernel, and it has a fan, which means it's a little bit louder, but also a lot more powerful. It's like twice as fast as the Pi 4. Then we have the Pi 4 and one unusual non-Pi device, which is the PC Engine's APU, a pretty old embedded board at this point. But it's not so important that it's the PC Engine's APU specifically on which we test. It's more important like which sort of kernels do we offer. And by now we have like this whole map of supported kernels, some of which officially supported, others supported by the community. Personally, my goal with Gokrazy was that there's only 4 moving parts, right? And the Raspberry Pi Foundation is none of the 4 moving parts. So I wanted to take the kernel from kernel.org and get the security updates immediately. And that works beautifully on the Pi 3 and also on the Pi 4 and the Pi Zero 2W, but the Pi 5 just isn't supported yet. People are working on it, but it's just not there yet. So aside from also the Raspberry Pi kernel for devices like the Pi 5, by now we also have these generic kernels, like a generic kernel for any AMD 64 PC or any ARM PC or VM. So by now I think Gokrazy can run on so many different computers. There should be something in there for you. We have a couple of community-supported kernels for other single boards, like the Odroid series of embedded devices or the Pine Rock64. And if you're interested in adding support for the particular single board computer you like most, talk to us and we can probably figure it out. So once you have Gokrazy installed, what does it look like in terms of the supply chain? It turns out that in Gokrazy, all of the modules, like we only use Go modules, right? So everything that you add to it and every component of Gokrazy that is part of the system is a Go module, including also the kernel builds that I just showed you and the firmware files. But most notably, like for your own programs, like for your own servers and developments, and anything else. It's all Go modules. So that means that you can use any tools that you are already familiar with from Go. So you can use Go vulncheck to discover security vulnerabilities. You can use the replace directive for patching these builds on your local system to fix a security vulnerability. And when you use Gok update, the whole Gokrazy system will be updated over HTTP or HTTPS, depending on whether you're inside a VPN or over an insecure link. You can automate this step, like the Gok update step, by configuring it just as like a systemd timer or a cron job, or if you want even more control, you can just say, okay, I'm just going to update my devices manually every month, or whatever you want to do, the model is there and it can be made to work. So there are a couple of nice properties that the Gokrazy system has and a couple of advantages that that gives us. And I just want to point them out specifically. So the configuration that we have, like the config.json file that you saw on the earlier slide, is a declarative configuration file. And the builds are fully reproducible, because Go builds can be fully reproducible, and also version locked, also thanks to Go's like go.mod and go.sum files. So that means that if you have a Gokrazy system configured on your computer, and then you copy it over to your friend, you can be sure that they build exactly the same thing. And the state is very clearly separated. So in Gokrazy, everything is read-only, and everything that you don't want read-only, you need to put it into a separate partition, into the /perm partition for permanent data. This model gives me minimal time to recovery. So whenever an SD card breaks, and I've had this like 2 times over the last 10 years that an SD card broke, I can just take out the SD card, grab my spare SD card from the drawer, use Gok override with that config, and then restore the /perm backup. And I need like less than a minute to do this. So whenever I notice that something isn't quite working right, I can just be like, okay, if in doubt, SD card goes out, new one comes in, redeploy, right? All right, so that's pretty cool, but we don't only self-build stuff, we might also want to self-host stuff. Not everybody can like build their home in Go. So what do we need if we want to escalate this to web hosting? I think there are 3 things. We need fundamentally an internet connection. In fact, did you notice that my smart home doesn't need an internet connection? Like it's entirely local and offline. We might need sufficiently powered hardware. And maybe we need more power than a Pi. Specifically, I just told you, like the storage is one of the first things that fails. So maybe you would want more reliable storage than an SD card or a USB stick. And also you will need server software and a way to run said server software, which might be Gokrazy. So let's first talk about the internet connection. If you want to host private services, any internet connection should be fine. Caveat, I wrote this slide before I came to Germany, so I'm sorry. So in theory, in most countries, even your home internet connection might be fast enough. But if you want to host public services, I would recommend using fiber to the home for low latency. And it's even better, of course, if your connection is unmetered, so if you have a flat rate, because then you don't need to care about how much data people are transferring. Now, to be clear, neither of these are deal breakers. They're just inconvenient, right? So if you have limited speed, you might need to set up traffic shaping or QoS or something like that. If you have limited traffic, you might need to set up rate limiting and monitoring and so on. It's just more stuff for you to do. So the better you can start out there, the easier you'll have it. Then, of course, you have that problem with the IP addresses. So whenever you have like an internet connection, you also need addresses to reach other people. And the first question is, does your ISP even give you a public IPv4 and or an IPv6 address, right? So maybe you're in luck. Maybe your ISP gives you one address family in a good way and the other one not at all or in a shitty way. And then you can just tunnel the other one. Of course, it's also effort. But some ISPs might just deploy CGNet, carrier-grade address translation, and then they will not give you a public IP address at all. One nice little social engineering hack is you call the support line of the ISP and tell them, hey, I'm having trouble with this online game, like it says something about port unreachable, and then they might be able to just change your connection to no longer use CGNet. Don't tell them about hosting. Then you might have the problem of a changing IP address. So with many of the ISPs, at least in Germany, IP addresses might change. So you might need to set up a DIN DNS to get a name that always points to your current IP address. Then you might have the fundamental question of, well, are incoming connections actually even allowed? Some ISPs block that on a technical level, like not flat out, but sometimes some of the ports, like blocking port 25 for email is like a very common one. And some ISPs also do it at the contractual level. Like they will just have a clause in there saying you just are not allowed to self-host. Luckily, none of these will actually look at individual customers, I don't think so. Anyway, so if your home internet connection just isn't good enough for any one of these reasons, you can just go where the internet is, right? You can go to, for example, an ISP. Of course, then you're not like self-hosting it all the way, you're just self-hosting at an ISP, but I would say that's actually better to self-host at an ISP than to obtain a service provided by somebody else, because you still have a lot more control, right? And if the ISP is shit, you just go to a different ISP, like they're very interchangeable, mostly. You don't have to go to a provider. There are also community efforts. You could go to Community Rack, for example, put in your own hardware in like a shared rack, or share it with a couple of friends, or just drop a Raspberry Pi at a friend's house, something like that. You'll find a solution. So with the internet out of the way, let's talk about hardware selection. So I already explained a couple of Pis and how they use very little power. For me, power usage is an important factor, like how much watts does the device draw out of the wall, because it also influences the heat development, especially in days like this one. Then, of course, the other question is space usage. How much physical space will your server or device need? Very closely related to space usage is where do you place it and how loud can it be? If you have like your own house and a garage, that's great, just put a rack in there and be happy, but many people just live in smaller flats in like a city, and for me, for example, the devices that I run in my living room, like I still want guests to be able to sleep in that living room so they can't be too loud, for example. Then we have the question of upgradability and repairability. Can we add more extension cards? Can we add more RAM, more disks? You might need that sooner or later, or depending on your use case. And lastly, performance. How fast is that machine? So I have this confusing slide with like a lot of bullet points, but I'm going to try to explain you like my lay of the land in terms of the spectrum of compute power. So I think like the smallest that we can start with is like a microcontroller, like an ESP32, for example. It will consume a low number of single-digit watts of power. And the next step up is sort of a single-board computer, like an SBC, like the Raspberry Pi, which is in the same area and it just uses a little bit more, like mid-single-digit watts. Now, how does that compare, like the sort of microcontroller and SBC part of the spectrum to more powerful stuff? Well, I think the performance is not going to be great, but it might be sufficient for what you want to do. The upgradability in general, not great. Peripherals, easy to add, because that's sort of the thing that microcontrollers and SBCs are built for. Low noise, often a given, but not always. Like the Pi 5 now has a loud fan, so Space efficient, usually, but they often need a case, and then that gets bigger, and then you have cables, so it uses a lot of space, actually. Low power, yeah, definitely, right? If you recognize, okay, microcontroller not good enough for me, I need more. I think the most promising servers for most people are actually mini PCs, and I'm going to show you a specific one in a second. But these generally use like low double-digit watts. They have great performance nowadays, just because computers have gotten so much faster. They're pretty good with regards to upgradability. Like you can typically add at least a PCI Express card or like some external Thunderbolt device or something. They're pretty low noise, they're pretty space efficient, they don't use a lot of power, and if you want to escalate one step further, you go from a mini PC to a full-size PC. And then you just consume a lot more power, but you'll also get a lot more performance, a lot more upgradability, but it uses more space, and the low noise, you'll have to fight for it. But one thing that I do not recommend specifically is to use 19-inch servers, because they use triple-digit watts, they're not built for your home. They are actually optimized for efficiency over performance, so you might see that your server, the 19-inch server, is actually a lot slower than your mini PC if you run an individual application on it. It only becomes like more efficient as you aggregate like, I don't know, hundreds of VMs, and you probably won't. These are super noisy. Sure, they are space efficient, but they draw a lot of power. So I just think you should stick to either mini PCs or full-size PCs if a microcontroller is not sufficient. In particular, I have this mini PC, which I bought last year, and I have a blog post about it, and I think this is like the greatest mini PC I know. It is the mini PC that is very small, but just about large enough that you can add a full-size Noctua fan, which means it's going to be super silent. It uses less than 10 watts, and you can add your own CPU, RAM, and SSD storage. So I put in a Ryzen 7 8700, maxed it out with 64 gigs of RAM and 2 M.2 SSD storage in there, and it's much faster than any sort of commercial VM I rented before from the other providers. So I really think if a Raspberry Pi doesn't cut it, this is the sweet spot. You'll probably want something like this. Now, I escalated a little bit here. So I needed more oomph because I needed more network ports. So I needed multiple different PCIe slots because my ISP actually introduced a 25 gig internet option. And when somebody comes to you and asks you, do you want 25 gig internet, you say yes. Of course, I had to upgrade. I have a blog post there about how it went. I recommend you read up on it if you haven't. And I also have this PC router/server build. So you can see that I built that in 2021 already. So like, it's not necessarily a build recommendation, but I did document how I chose the components and so on. And one fun fact to note here is that Linux can in fact satisfy 25 gigs without any tuning, as long as you make sure that you use TCP/BBR, which is the default in most of the distributions. So these days, you can probably just install a standard Linux on such a PC, and you will have enough capacity to serve content at 25 gigs to the internet, which is pretty impressive. So let's talk about the software that you need. So for my router, I actually didn't use a PC. For the longest time, I used to use the Turris Omnia, which many of you might know from, I don't know, 10 years ago or so. It was like a very popular open source hardware. It was entirely open hardware. And I bought it because it had automated updates. And then it annoyed me because it had automated updates. Because one of their automated updates actually broke my IPv6 connectivity. And the problem was that I could actually debug why it broke. And then I told like both the developer of the DHCPv6 client and also my ISP, and both were not in a position to fix it for different reasons. So ultimately, it was faster to actually implement my own router compared to waiting for any of them to fix it. And I had a similar moment to how I said earlier that Gokrazy was created when we just realized, oh, it's so easy. And for a router, it's actually also pretty easy. Like my first prototype was I just used a Raspberry Pi, added another USB Ethernet interface so that I had 2 ports on it. And then I enabled IP forwarding, which is all you need for IPv6. If you want to use IPv4, you also need network address translation. And aside from that, you only need a couple of small programs to implement the control plane. So you need all of the addressing stuff, so DHCP v4 client and v6 client, DNS forwarder, and then for the internal network also a server for v4 and v6. But once you have all of that, you have a router. So I have my own router written in Go, and you can do a couple of cool things which I want to show you just for inspiration on top of having your own router. So when you have your router and you use it, for example, to, I don't know, tunnel some traffic for an event or something, and you then go to that event, you might want to have some sort of out-of-band access to your router. The easiest might be just to power cycle it. Like, if you apply a bad configuration, maybe you just want to be like, oh, turn it back off and on again and just boot with the old configuration. I found that an easy and very pragmatic way to do this is to just use a smart plug, because you can combine a smart plug with like a travel router and a cheap subscription, and then you just connect to that, and you have like your own out-of-band. You can go one step further, which is if you also want serial console and not just power management, you can use a Pi02W, like I showed earlier, which consumes barely any power. And then you would put a program onto it, like conserve, which Matt Layer wrote together with me on stream. So if you actually want to look at how did we develop this for Gokrazy, you can watch that recording and see how we built it. And conserve is an SSH to serial console bridge. So it allows you to just SSH into that Pi, and then you will have commands for like power management via smart plug or attached USB to serials and so on. You can do all of the things. I like to combine that with the Tailscale Mesh VPN, because then I also get connectivity through like carrier-grade NAT and anything else on mobile networks, and also access control. So to me, that's sort of the all-in-one solution. If you want to go a step up, of course you can. There are ready-made devices for this. You can just buy like a Tiny Pilot or a Pi KVM or something like that. And that will give you HDMI access and remote keyboard access and even remote media emulation, so you can like boot an ISO image of an installer and reinstall your machine remotely and so on. But they're just much more expensive in comparison. So the Tiny Pilot, for example, comes in at $400 US. The Pi KVM is at over 200 when I last looked. For comparison, the Smart Plug mobile router and the Pi 02W comes out in total at a little over 100. So yeah, maybe that's just about pragmatic enough for some of you. So on that router/server, I run Gokrazy, as I mentioned, with like the Router 7 self-built router. And on top of that, I run the Caddy web server for my public website hosting. So the Caddy web server, to me, like I used to use Lightheat and Nginx and Apache in like the olden days. And when I discovered Caddy, I was so happy because it does HTTPS for you in a managed way. So you no longer need these Rube Goldberg machines of certbot and Nginx config and so on. And it was just always inconvenient. And in Caddy, you can just say, look, this is my config file, and it'll do the HTTPS for you. Like, in fact, this is the full Caddy file here on slide that I'm using to serve i3wm.org right now. So if you open that website, this will be the config that you hit. You can see that it contains barely anything. Like, it only says, from the bottom to the top, serve static files from that directory and log, right? And that's all. So I love it. I would recommend it. How do I update the static files that I have on my server? Well, for some of the projects, I still use that model where I have like my static files in a Git repository so that other people can contribute to them. And then I just pull that Git repository onto my server. And for others where I don't expect other people to contribute, it's just like my own stuff, I just have a push script. So for example, for my website, I just run Hugo, the static site generator, and then I run an rsync command to just sync these files onto my router, and from there on out, Caddy will pick them up immediately. Similarly, I do DNS hosting using Core DNS. Core DNS is a Caddy-inspired DNS server, which is pretty cool that Caddy has been around and so influential for so long that it has like whole servers inspired by it. But I think it makes sense. And Core DNS was similarly like a breath of fresh air compared to setting up, I don't know, a bind server 10 years ago. So it's very easy actually to serve like a managed directory of DNS zone files. So all I needed for that is this configuration here where I just essentially say bind on this example IP address and then look into this directory for zone files and reload them every 10 seconds. So in addition to that, I have like a simple Go program which just does templating for DNS zones so that I don't need to like increment zone serial numbers manually or with like an editor plugin or something. And I also have like this tiny little bit of templating in there so that I can put the public IPv4 address that my router currently has into the zone file right then and there. And the way I have this wired up is I don't run like DNS servers myself, aside from that one, but that one doesn't serve end-user traffic. Like it functions as what's called a hidden primary. And this is a typical setup in the DNS space. So I have all of my domains registered at INWX, Internetworks in Berlin, and they offer a hidden primary setup. So I just went into the web interface and told them, look, my server listens on this particular IP address. It's an IPv6 address because I get static IPv6 from my provider for free. And then I just configured, okay, the INWX server is now allowed to transfer that zone, and that's the configuration you see at the bottom here. So that's all you need in Core DNS to set up a hidden primary. What I really like is that I don't have like a static IPv4 because I would need to pay money for that. And I just don't want to pay more money for IPv4 because it's not the future. So I get IPv6 for free and static. So the cool thing is that because INWX supports both IPv4 or IPv6, I have like DIN DNS for free because whenever my IPv4 changes, they use IPv6 for the zone transfer and then they pick up my change to the IP address. So I sort of accidentally implemented DIN DNS. All right, so that was web hosting for public services, where I would recommend to just use Gokrazy and use Go programs as much as you can. I think it's great, it's simple, it gets you pretty far. But what if you also want to do web hosting for some private services which you haven't written yourself, which aren't necessarily written in Go, like maybe you just want to use something off the shelf? My old approach was, the first time I got into sort of running my own network storage, I just figured, okay, I'll just pick a commercial off-the-shelf network storage. So I bought a QNAP device because the QNAP ones, they were comparatively well explored and open source compatible. Like I found these blog posts about how people had net installed Debian onto them, and there were these instructions for how you could solder your own serial port adapter for it. And I bought it, I installed it, and it worked. And while it was technically possible to do all of that, like all of these speed bumps in the way resulted in me feeling not very well equipped for maintenance and for recovery. And it was just always like an annoying thing to change that device, so hence I just didn't update it very often. There are multiple different ways in which a system can be closed. Like some of them are inadvertently closed, like this one where it's just not convenient for me to interface with it. But nowadays, some commercial vendors are even intentionally closing their systems. So you might have seen that Synology, for example, no longer allows you to put in any disk drive that you bought into your network storages. And I'm just like, man, that can't be the solution. So I self-built my network storages by now, and I think that's actually a great step up from having sort of a mini off-the-shelf network storage. The most recent iteration of this is documented in this blog post I'll link here. It's like, you can see the case here, it's a little bit larger than the mini PCs I showed you earlier, and the reason for it is that I wanted to have the physical space to put in SATA SSDs, right? Because those were much cheaper than M2 SSDs, at least for the longest time. But maybe nowadays you could actually get by with a smaller system even. But what's important about it is that these are just standard PC components. So I can just connect an HDMI monitor, I can connect a USB keyboard, I don't need to wire up like my custom serial adapter and netboot it. It's much easier for maintenance, and it's also much easier to get spare parts, because if something breaks, I mean, first of all, I have 2 of those, so I don't really care if one of them breaks, but I will want to fix it eventually. So I can just order the part at my local computer store and maybe pick it up the same day or the next day, and then I can just continue. And like with all of these like super targeted, maybe commercial, maybe not solutions, you're always in a bad situation if you want to get spare parts. So in terms of software, on this machine, I set up Samba, which is pretty easy to set up, pretty standard. I use rsync for my backups, as I said, and I just run Jellyfin for my media collection. I used to use CoreOS for my network storage, and then I switched to Flatcar. Both of these are declarative Linux distributions, but one issue that I noted is that Flatcar does not support Docker Compose. It only supports Docker. And the problem is that nowadays, web applications like Image and others, they just assume that you have a system available like Docker Compose, where you can just say, look, I need a web server, and I also need a Postgres, and I also need a Redis, and I need this and that, and it just can't be complicated. Like, these are like standard things that you want to do nowadays. Unfortunately, in the CoreOS model, they were like very adamantly, it's only individual containers, and you have to do the glue code yourself. So I started looking for an alternative. And I wanted something that mostly works like Gokrazy, but it gives me access to more non-Go software. And to me, that is NixOS. And I published a blog post this month, actually, how I like to install NixOS declaratively. Because there's like so much stuff in NixOS, you can use it this way or the other way. And I think I had sort of this model in my mind of Gokrazy works like that, I just want to have that model, but for more stuff. And I can make that work in NixOS. So what I find is that the level of abstractions that we have in NixOS, they're just a little higher than elsewhere, and they seem to work better, like they compose better. So for example, once I had my previously Flatcar installation migrated over to NixOS, trying out Image became extremely simple, because I just need these few lines in my configuration.nix, and then it just does all of the rest, right? And I just found that very impressive. And the other thing that I really liked about Nix is that once I had like Image installed on my server, I wanted to also then use the Image CLI to upload my pictures to my server. And I could just use the exact same package in the exact same version on my Arch Linux PC, even though I didn't actually have NixOS installed there, just the Nix tool itself. But I can just run that software and then just use the same version of the CLI. So there's never going to be incompatibilities or something like that. All right, so in conclusion, over like these like, I don't know, 10 plus years of working in that space, I can definitely recommend declarative configuration. I think it's much better than imperative configuration. I can also recommend the appliance model, meaning you have purpose-built devices that have a clear failure domain, a clear privacy domain, that have a read-only root file system and very clearly separated state. In Gokrazy, that would be the entire /perm partition. I'll also recommend running daily backups. Following the 3-to-1 rule, I think it's good. And I will recommend writing services in Go, because they're reliable, they just work, and using Go software in general. I would caution against any sort of vendor lock-in or building like too specialized setups and platforms. And I would also caution against mixing things carelessly between failure and privacy domains. These are like the, I'm going to say typical nerd traps where you get so carried away with your like super cool setup that at some point it breaks and everything is broken and you're super frustrated, right? Don't do that. Build small increments. All right, so this is the end of my presentation. I hope I could inspire you with that to run something, anything really, on like a small-ish computer. There's lots of choices. If you have any questions, talk to me after the presentation. I'm always happy to talk about that sort of thing. And I've put a QR code here on the slide, which you can give me some feedback on this presentation. I would love to hear if you found it useful. So with that, thank you so much.